Hi, my name is Vahan Davudian. I'm a physics experimentalist for 34 years, and today our topic is rocket propulsion. And this is the logo I created, and this is my design. And then if you click on this green circle, you can watch all my 70 theories all the way to year 2000. And why do I call this a unique physics concept by Vahan Davudian? Because most of my experiments are unique. I haven't seen in any books, and on top of that, always, I give a little bit history. And I remember in the year 2022, when I published General Relativity. That was great success. The reason why I had to go back 400 years, even before Albert Einstein. And my idea was, if I go in a public, if I go in universities or colleges, ask people, who did general relativity right off the bat or immediately? People say Albert Einstein. I said, no, you have to go back to see who started. And Copernicus, one of the greatest minds in history, he started. And his idea was our perception of the universe, it depends on where we are. And he's absolutely right. I give you a good example. If you're talking about solar eclipse, there is a path, it's called path of totality. If you're not in the same path, you won't be able to see 100% of the solar eclipse. So it depends on how far you are from that totality, you can see partial. It depends on if you're so far away, you might even see 50% of. Same thing happened to us in Portland, Oregon. I remember we were like a little bit far away from the totality, we saw almost 90%. And in fact, this is so important that the human's life, and then the rocket propulsion started, because I have to give you a history, you understand exactly what happened, how did it started. It started from 9th century in China, and then you can see those days they call this gunpowder, and then you can see this Chinese soldier, and then it was not even metal, and I bet those days it was not even discovered yet. So they had to use bamboo like this and then fill it out with explosive, and then they were using this so like a weapon and sometimes to scare the enemies or something like that. But the gunpowder was amazing discovery. I mean, after that I will explain what happened, and then we had a rocket, and then we went to the moon and so many other things. And this gunpowder was amazing. And it's a combination of potassium nitrate, like 75%, and then 15% carbon and 10% sulfur. So what happened when they react? They create a lot of gas, and that gas expands a lot. So that's why we call this action reaction. And thanks to Sir Isaac Newton, after 300 years, we use the same idea, his third law of motion, action and reaction. It doesn't matter if you have it like a gun, rifle, or rocket. I'm sorry, it doesn't matter. They work in the same principle. Always we have action and reaction. Then you can see they would fill this bamboo with explosive and do this. And this is the picture of the explosive gunpowder. And then this is an old picture, and they would scare the enemies. But the amazing thing is, Chinese people, those days they had no idea about the action and reaction. It would take another maybe centuries, and then Sir Isaac Newton came over and talk about like action and reaction. Well, of course I have to mention two great minds in a history. One of them was Werner von Braun from Germany, and then the other one was Konstantin Tsiolkovsky from Russia. Their contribution was amazing. I will explain when we go step by step how they did it and what they did it. And in fact, I had this picture over here. You can see how easy it is to understand what a rocket propulsion is. And in fact, this is the administration, NASA administration. Then this one shows perfect, this is a perfect picture. It shows everything. You see, this is a lift off here, and then RTLC turns. Then what we have here, we have two boosters. Because I have to explain what Mr. Konstantin Tsiolkovsky said. He said, it is impossible for the human with one stage go to the not even moon, anywhere. So he was absolutely right. So what they do nowadays, they have boosters like this. So because the gravity is there, and then we have to, overcome that gravity, and then after that they detach. And then what they do, they fall in the ocean. But of course, these rockets are so good, we can reuse them over and over again. And then we have also external tank. You know how heavy it is when we have everything attached to the shuttle. Then after that, this rocket, this gas tank fills. Well, of course, this one burns. Then what happened? Shuttle comes and then turn over, see, like that. And then gradually, it almost orbits the Earth almost like 30 days, and then gradually, comes and then change orientation. Well, of course, because, the shuttle is not using any engine, they have to stop it somehow. And then the most important thing for that is a huge, chutes. Then they deploy it, and on top of that, they just use the brakes. So let me put the other poster so you can see how these rockets work. This is another one. Well, of course, these are simple pictures of the rockets, and then you can see whenever the rocket is on the floor, on the pad, I would say, you can see it's exactly, you see these red arrows and the green arrows, blue arrows, is exactly pushing on Earth. So Earth is exactly pushing opposite, which is action and reaction. The reason why I'm standing over here, because I'm 80 kilograms, and then my 80 kilograms is pushing on Earth, and then Earth is also pushing on me 80 kilograms. So that's why I don't fly in space. That's why I'm standing over here and talking to you, because everything is, same. So this is exactly what happened to rocket. Well, whenever we have this, ignited, and then what happened, like I said a few minutes ago, always these gases, ignite, and then it's a lot of pressure. So that pressure, what happened, push this, so which is, action, and then the reaction is it goes to the opposite side. Well, of course, there is something I have to mention. Unfortunately, with the technology we have now, we won't be able to go to the Mars because of the fuel problems. Moon is not a big problem. I think we can go. We have done that before. But you know what? There is a experimental thing for the future. Well, of course, I'm hoping this will, maybe it's not going to be my lifetime, but if this happened, we can go almost, maybe 90% the speed of light. But this is a nuclear fusion. Well, of course, we can also use fission, but unfortunately, the byproducts are always radioactivity, which is not good in space. But the fission is so good, but there's a problem. That means it's a huge, when we're talking about the space, we cannot have. Like this one is called TOKAMAK. This is in Seattle, Washington, and they do that. Well, this is amazing technology, and all these reactors, we need, hot water, or, we need heat. So these reactors, they use, sometimes plutonium and some other things. But this is amazing. This is exactly replicating what happened inside the sun. So, well, of course, we won't be able to do it, but in a smaller scale, this is called tokamak, and then what they do in sun, if you recall, 4 hydrogen nucleons combine, and then because of extreme pressure, gravity, and then the pressure and the heat, and then they fuse and they made helium, nuclear. And then that helium, what happened, gives us energy. Part of it is the light and part of it is energy. But imagine we're talking about huge scale. But this tokamak, if this happened one day, this comes true, we'll be able to go almost 90%, 85% the speed of light, and then we'll be able to go even to Mars and beyond. And this is the rocket. I have to mention something important. Always, Mr. Konstantin Tsiolkovsky, he was the pioneer. He said you need hydrogen and oxygen. When I think about that, those days, it was a long time ago, he was absolutely right. But now it's changed. Sometimes they get gasoline, and then oxygen. But imagine those days they were thinking they can have the gas, and that is so bad, because the reason why it occupies a big volume. But now they realize, Mr. Konstantin Tsiolkovsky said, we have to use liquid propellant and liquid oxygen. So that's what they do, and then that is the way nowadays we use for rockets. Well, of course, there's another great scientist. I'm sure all of you know him. He is one of the greatest minds in history, and he was the one who took us to the moon, one of the great scientists. His name was Werner von Braun from Germany. And then after World War, they came to United States. And then God knows his contribution to space was amazing. And he was the best rocket scientist in the whole world. Well, of course, they had a team with him. I don't know, 28 or 29 people, all engineers. They came over, and then United States was so happy. They just harbored them, and then they came over. They peacefully worked, and then they took us to the moon, which was great. Great success. And this is the V2 rocket, and this was the most important thing happened in history, and that was his idea, Mr. Werner von Braun's idea. And this is going almost like 320 kilometers, the range, and then can fly almost 88 kilometers in space. And this is in fact a guided missile. It's not even an ordinary rocket, and this is using not like oxygen and hydrogen. This is using nitrogen tetroxide and hydrogen like a propellant. But nowadays, most rockets that we use for moon, they were using gasoline and liquid oxygen. The reason why you have to have always oxidizer. So this is the one Mr. von Braun did, and then we were so successful. And this is a picture of Konstantin Tsiolkovsky, and he was an amazing scientist. He was a school teacher, but he was almost 100 years ahead of time. He said, we have to use Sir Isaac Newton's idea for the third law of motion, and then the reason why we can use hydrogen and oxygen. And the most important contribution was, no one knew that, those days we have to use multi-stage in order to go in space. When we're talking about like moon, it's not easy. It takes almost 5 days. So imagine if we don't have those rocket boosters, and then what they do, they overcome the gravity, and then we can propel, because we're talking about hundreds and hundreds of tons. So Mr. Tsiolkovsky did this, and then this is the Atlantis. I will explain in a minute. So let me put this down. I have another one. Well, of course, I have to mention this rocket propulsion with, like solid fuels, or, like a liquid item, oxygen and hydrogen. It is not the only way we can go in space. But unfortunately, there are so many others. They're not powerful enough. One of them is so important. It's called ion propulsion, and it is using charged particles. So they're using mercury, and it's heated so good like a plasma, and then always the charges go from positive to negative. And of course, unfortunately, the bad thing about this is that mercury, a bottle of mercury can work forever. But the point is the propulsion is not good for the humans to go to space, and that's why we stick to the old technology, which is, huge rockets. Of course, there's another one which is experimental. They call it solar sail. I show you. Well, of course, this is small. This is highly reflective things. They're huge, like 20 square meter by 20 square meter. The reason why they use this, because whenever sun hits this in a right angle like that, the propulsion is so good. Well, of course, it's not powerful enough. When it hits in a angle like this, it's not good enough. But that is so important. This is experimental. Whenever photon hits a reflective mark, even mirror or reflective like this, so the momentum is 200%. And 200%, what happened is propelling that in the opposite direction. Well, of course, I haven't seen anyone use this, but this is just the experimental, so people were talking about this as another way of propulsion in space. But I'm hoping, like I said a few minutes ago, if we can use the nuclear fusion, which is, in the horizon, and then they are using, two, things from the, let me see, I think I have it over here. Yeah, if we can use that, that is going to be breakthrough in science. But in fact, one important thing about the rocket propulsion, it was proposed with Sir Isaac Newton 300 years ago. They call it escape velocity. That is so important. Each planet has, when I'm standing over here, I am accelerating toward the center of the Earth. So escape velocity for the Earth is different, Moon is different, Mars is different. So it depends on how strong the gravity is, or what is the rate of acceleration toward the center of that planet. Like I said, Earth is 6.96 miles per hour, or or 11.2 kilometers per second. Imagine that is a lot. You have to travel 11.2 kilometers in second in order to escape this velocity, to escape from the gravity. And then when you go like 10, 20 miles, and then after that, it's going to be easy because there is no air, nothing. Well, of course, I have to mention a misconception for the rockets. Even the old days, Mr. Konstantin Tilskovsky knew about that. The amazing thing about the, rockets, it is not like airplane, If you're flying from California to Kansas City or anywhere, you can use aerodynamic because, the airplanes are using laws of aerodynamic. And then, there's the air, there's the atmosphere. But for the, rocket propulsion, we don't need. The reason why, we have this action and reaction, even in empty space, even in vacuum, that, whenever that burn the fuel, that fuel is burned, what happened is pushing against its own, supply, and then it's pushing action and the reaction. So, well, it depends on how long will it last, and then when it finishes, and then it won't do anything else. And then rocket stability, rocket is supposed to be stable. The reason why, like I said, when you go 10, 15 kilometers above the atmosphere, then what happened? There is no air. Then what happened? You have to use your propulsion, and then in order to get the orientation for your, rocket, and then everything is done by the engine. And imagine all those satellites we have in space, and then we're using communication, we're using telephone, we're using television and everything else. Even though we're not far away, some of them are 22, 23 kilometers above the atmosphere. So what they do, they use the propulsion. So if they don't, there is no air, there is no aerodynamic. They also use the same concept. All these small satellites, they have a small, engine. Whenever the orientation is not good, they use it so they can go in the same orbit, they can, correct their orbit. This is another poster. probably this was the best moment in my life. This was that was 12 November 1995. I was in Florida. We were vacationing with my kids in Florida, and God knows we got up like 6 o'clock in the morning. This was supposed to be launched at 11:30, I think, and it's called Atlantis STS-74. And I remember we were there almost like 6-7 hours ahead of time, and then we waited and waited. Well, of course it was far away, well, we could see everything, and this was called Atlantis. And then this was the first time in my life I saw, you know, exactly how they launched that. That was huge complex. Well, of course, like I said, Mr. Tiskowski said, everything is so important if you consider the fact that, you know, we have action and reaction. And my best example for the rocket is the rifle. And imagine you have a bullet in your, rifle, and then you have the barrel, and then what happened when you ignite that bullet? What happened is confined in that, you know, barrel. There's no way to go, and that expanding gases are pushing action and reaction, so the bullet goes. It depends on how big the bullet is, how much the explosives are, and that's exactly what happened. So what happened in 9th century is happening now. Well, of course, we have more advanced, you know, like guns and then weapons and everything else, but the principle is exactly the same. So we have always action and reaction. It doesn't matter, small guns or the rifle, always the bullet is propelled because of the, you know, action and reaction, and because of those explosives. So I'm hoping you guys will love this theory, you love this presentation or video, and if you like it, you can go ahead and subscribe it. And I appreciate you all always, you know, your feedback is so important, and your ideas always I put it in action, and then always, you know, I honor your ideas. Thanks a lot for watching.